Right now, a severe weather forecasting index used to predict violent tornadoes is spiking to levels normally reserved for the Great Plains in May, but it is happening in the far northern United States in midsummer. This shocking metric is merely the opening phase. A locked, 10-day jet stream pattern is triggering a triple threat: rare northern tornadoes, a multi-day severe weather siege moving down the eastern seaboard, and a brewing tropical threat in southern waters. By the end of this video, we'll know the exact timeline and why forecasters are warning of deadly consequences. The atmosphere is a fluid, and right now, that fluid is trapped in one of the most volatile configurations possible. To understand the sheer scale of the triple threat bearing down on the eastern half of the continent, you have to pull back and look at the entire northern hemisphere. The overarching meteorological pattern driving all of this chaos is something atmospheric scientists refer to as a dipole. A dipole is exactly what it sounds like: two massive, intensely powerful, and completely opposite poles of atmospheric pressure existing side by side. In the western and central parts of the continent, an absolute monster of a high-pressure heat dome has anchored itself into the Earth. It is a sprawling, suffocating mountain of sinking air that is actively rewriting all-time temperature records. But right next to it, parked over the eastern half of the continent, sits its exact physical opposite: a deep, persistent atmospheric trough, a massive valley of low pressure and cooler air aloft. These two gigantic features are not just sitting next to each other. They are interacting, they are fighting, and the boundary where these two opposing air masses meet is where the disaster is being manufactured. The engine driving this entire event is the jet stream. Normally, the jet stream flows relatively smoothly from west to east, rippling gently across the country. But when a dipole sets up, the jet stream is forced to navigate a massive obstacle course. It has to climb all the way up and over the top of the western heat dome, and then plunge violently down into the base of the eastern trough. This plunging corridor of upper-level wind creates what is effectively a high-speed atmospheric conveyor belt. And this is not a slow, meandering breeze. We are talking about a concentrated ribbon of wind screaming through the upper atmosphere at well over 100 miles per hour. This high-speed conveyor belt is sliding directly over the top of a surface environment that is completely saturated with midsummer heat and Gulf of Mexico moisture. It is continuously pulling massive amounts of storm-generating energy into a highly unstable environment. The jet stream is acting like an industrial vacuum, exhausting the air at the top of the atmosphere so rapidly that the air at the surface is forced to violently rise to replace it. This single, unbroken conveyor belt is the solitary mechanism responsible for three completely distinct geographical disasters that will play out over the next 10 days. The first phase of this siege is happening right now, and it is happening in a place that is completely unaccustomed to this level of atmospheric violence. We are watching the ignition of an out-of-place tornado outbreak in the far northern tier of the United States. Under normal midsummer conditions, the far north experiences standard, disorganized thunderstorms. They are messy, they produce some rain, maybe some small hail, and then they collapse under their own weight. They do not spin, and they do not last. But the locked dipole pattern has fundamentally altered the ingredients over the northern states. To build a violent rotating supercell, the kind of storm that drops long-track tornadoes, you need two very specific things to overlap perfectly: extreme atmospheric instability and extreme wind shear. Usually, you only find this perfect overlap in places like Oklahoma or Kansas during the spring transition months. In the summer, the north might get the heat, but the jet stream retreats into Canada, taking the wind shear with it. Not this week. The plunging conveyor belt of the jet stream has dragged winter-like wind dynamics directly over the top of summer-like surface heat. This is the atmospheric equivalent of pouring liquid oxygen onto a grease fire. The instability provides the rocket fuel. As the intense July sun bakes the surface, the heat and moisture become trapped near the ground. Meanwhile, the jet stream is pulling unseasonably cold air into the upper levels of the atmosphere right above it. This massive temperature difference between the hot ground and the freezing upper atmosphere means that once a parcel of surface air is lifted, it will accelerate upward at terrifying speeds. We are seeing convective available potential energy, or CAPE, values surging into the extreme range. The updrafts inside these developing thunderstorms are rising at speeds exceeding 100 miles per hour straight up, but instability only makes a storm tall. Wind shear is what makes a storm dangerous. Wind shear is a change in wind speed and direction as you go higher into the atmosphere. Because the jet stream is screaming overhead, the winds at the surface are blowing in a completely different direction and at a vastly different speed than the winds at 30,000 feet. As the violent updrafts punch up into the atmosphere, this extreme wind shear tilts the storm over. This is a critical mechanical step. If a storm is perfectly vertical, the rain and hail fall right back down through the updraft, choking off the warm air and killing the storm in minutes. Because the shear tilts the storm, the heavy precipitation falls completely away from the updraft. The storm can breathe. It can ingest warm, moist air uninterrupted for hours. More importantly, the directional wind shear creates invisible, horizontal tubes of spinning air rolling along the surface. When the massive updraft of the thunderstorm encounters one of these rolling tubes, it acts like a vacuum, sucking the rotating air up into the cloud and tilting it vertically. The entire thunderstorm begins to rotate on a vertical axis. This rotating core is called a mesocyclone, and it is the birthplace of the tornado, The hazards associated with this northern setup are severe and compound. The intense updrafts are capable of suspending massive chunks of ice high in the freezing levels of the cloud for extended periods, resulting in giant, destructive hail the size of baseballs or larger. As the cold air inside the storm finally crashes to the ground, it spreads out rapidly, producing hurricane-force straight-line winds that can flatten forests and tear roofs from homes. And, because of the rotating mesocyclones, strong, potentially long-track tornadoes are a very real threat. The metric that has meteorologists so alarmed is the Significant Tornado Parameter, or STP. This is a composite index that calculates the exact combination of instability, shear, and low-level moisture. An STP value over 1 indicates a favorable environment for significant tornadoes. Right now, the STP values in the far north are spiking into the 5 to 7 range. These are numbers you expect to see outside of Oklahoma City in May. To see them in the far north, in the middle of summer, is a glaring red flag that the atmosphere is primed for an out-of-place disaster. But the northern threat is only Act 1. After these rotating supercells exhaust themselves and push eastward, the system does not simply clear out and grant us a beautiful week. The jet stream conveyor belt does not stop. It simply shifts slightly south, reloads its ammunition, and prepares for the next phase. Act 2 is a multi-day coastal siege. As the trough deepens and the western heat dome flexes, the high-speed winds aloft will transition into a pattern known as northwest flow. This means the steering winds will be pointing directly from the upper Midwest down through the Ohio Valley and straight into the mid-Atlantic and eastern seaboard. Over the course of the coming weekend, this exact corridor will become a superhighway for severe weather. Instead of isolated, spinning supercells, the primary threat will transition into massive, organized lines of thunderstorms known as mesoscale convective systems, or MCSs. Here's how the march plays out. Each afternoon, as the heat and humidity peak across the Midwest, a cluster of storms will ignite, but rather than dying off at sunset, the upper-level winds of the jet stream will grab these storms, organize them into a solid bowing line, and drive them southeastward through the night. These complexes thrive on the low-level jet, a fast-moving river of wind just above the surface that pumps moisture directly into the storm complex after dark, keeping it alive long after the sun goes down. The hazards in Act 2 shift from tornadoes to a widespread, devastating wind threat. As these massive squall lines race toward the coast, they can produce continuous swaths of damaging straight-line winds, occasionally accelerating into what is known as a derecho, a long-lived, rapidly moving windstorm that can travel hundreds of miles, knocking out power to millions and causing damage comparable to a mid-grade hurricane, but spread across multiple states. But the wind is only half of the coastal threat. The other half is water, and it comes in the form of a phenomenon meteorologists call training. When you watch a freight train go by, you see car after car after car passing over the exact same piece of track. In the atmosphere, training occurs when multiple thunderstorms line up and move over the exact same geographical area, one right after the other. Because the broader jet stream pattern is locked in place by the dipole, the steering currents are not moving. Therefore, the storms will continuously follow the exact same path for days. This is the perfect recipe for catastrophic flash flooding. The atmosphere is currently holding an anomalous amount of precipitable water. When training thunderstorms anchor themselves over the eastern seaboard, they can easily dump multiple inches of rain per hour. The ground can only absorb so much water. Once the soil reaches total saturation, every additional drop of rain immediately becomes runoff. In the heavily urbanized corridors of the East Coast, where concrete and asphalt have replaced natural soil, this runoff moves instantaneously. Small creeks turn into raging rivers in minutes. Highway underpasses fill with 10 feet of water without warning. The sheer weight and volume of this continuous training rainfall will overwhelm municipal drainage systems that were never engineered to handle the atmospheric output of a locked 10-day dipole pattern. And yet, as the eastern seaboard battles the flooding and the wind, the tail end of this massive atmospheric structure will be quietly setting the stage for Act 3. As the frontal boundary associated with the eastern trough sags violently southward, it will eventually lose its forward momentum. The cold air pushing it will exhaust itself. When this happens, the tail end of the front will completely stall out and drape itself over the incredibly warm waters of the Gulf of Mexico. Normally, a cold front moving off the coast just dies and dissipates over the ocean. But the Gulf of Mexico right now is not normal. The water temperatures are running near record highs, with a deep layer of extreme ocean heat content extending hundreds of feet below the surface. This water is high-octane rocket fuel for tropical cyclones. When a stationary boundary lingers over an environment this hot, something terrifying can happen. The front begins to decay, but the spin and the vorticity left behind by the boundary remain. This leftover atmospheric spin can pinch off from the main front, close off into its own independent circulation, and begin to feed directly off the latent heat of the 85-degree ocean water. This is how you build a homegrown tropical threat. It doesn't travel thousands of miles across the Atlantic from the coast of Africa. It drops right into our own backyard, spins up from scratch, and threatens the coastline with practically zero lead time. The system transitions from a cold core, baroclinic setup driven by temperature clashes, into a warm core, barotropic tropical system driven entirely by the evaporation and condensation of ocean water. But this is where the forecasting becomes incredibly complex, and where we have to be completely honest about model uncertainty. Predicting the birth of a homegrown tropical system is one of the most difficult tasks tasks in meteorology. The global supercomputers are currently locked in a massive disagreement about exactly what this stalling tail end will do. Some of the most reliable forecast models show this pinched-off energy organizing rapidly. In this scenario, the system closes off a tight center of circulation, rapidly intensifies over the superheated Gulf waters, and gets scooped up by the returning flow of the jet stream, throwing a localized but potent tropical storm or hurricane directly into the southern coastline. Other models, however, show a completely different reality. They suggest that the wind shear lingering from the massive dipole pattern will be too strong, tearing the top off the developing storm and preventing it from ever forming a closed, organized eye. But do not mistake a failure to organize for a failure to produce a disaster. If the system fails to become a named tropical storm, it will instead become an asymmetrical, sprawling, disorganized mess of tropical moisture. It will act like a giant atmospheric sponge, soaking up millions of tons of water from the Gulf of Mexico and dragging it slowly onshore. A weak, disorganized system often produces far more catastrophic, widespread flooding than a tight, fast-moving hurricane. The divergence in the computer models is perfectly normal at this range. It reflects the atmosphere's current indecision. But regardless of whether it gets a name or remains a disorganized tropical depression, the threat of massive coastal inundation remains identical. As we watch this triple threat unfold, the northern tornadoes, the eastern coastal siege, and the homegrown tropical system, it is critical to remember the anchor of this entire event. None of this is happening in a vacuum. The record-breaking heat dome parked over the western and central United States is not a separate news story. It is the exact same engine. The physics of planetary waves dictate that for every action, there is an equal and opposite atmospheric reaction. The stronger and hotter the high-pressure dome becomes in the west, the deeper and more violent the low-pressure trough becomes in the east. When you have a mountain of dense, sinking, superheated air out west, it creates an extreme pressure gradient. The atmosphere hates imbalances, but constantly attempts to equalize pressure. The wind is simply the atmosphere rushing from high pressure to low pressure in an attempt to balance the scales. Therefore, the hotter the heat wave in the west gets, the faster and more violently the jet stream winds will scream down its eastern edge. The western heat and the eastern severe weather are two faces of the exact same wave, and whenever a wave of this magnitude produces extreme continent-spanning violence, a predictable secondary phenomenon occurs. The rapid spread of conspiracy theories. Inevitably, viral posts and videos will begin claiming that a multi-hazard event of this scale is unnatural. They will claim that the storms are being artificially engineered, that the jet stream is being steered by secret government installations, or that cloud seeding is responsible for the tornadoes and the stalled fronts. We have to debunk this immediately, and we do it not with opinion, but with the undeniable mathematical laws of physics and energy. The conspiracy theories completely fail to grasp the incomprehensible scale of atmospheric energy. Let us look at the energy budget. A single, standard severe thunderstorm, just one of the thousands that will fire over the next 10 days, releases an amount of kinetic and thermal energy roughly equivalent to a 20-kiloton nuclear weapon every few minutes. Now, scale that up. To physically manipulate the jet stream, to build a continental high-pressure ridge, and to simultaneously steer a 10-day dipole pattern across millions of square miles, you would need to continuously inject the energy equivalent of tens of thousands of nuclear detonations into the atmosphere every single hour, for weeks on end. The entire electrical generating capacity of humanity, every coal plant, every nuclear reactor, every solar panel, and every wind turbine on the face of the Earth running at absolute maximum capacity, does not produce even a microscopic fraction of the raw wattage required to nudge a planetary Rossby wave. Cloud seeding is real, but it is a microscale operation. It involves flying a small plane and dropping silver iodide into an already existing, moisture-rich cloud to encourage a few extra drops of localized rain over a valley. You cannot cloud seed a violently rotating mesocyclone into existence. You cannot geoengineer a jet stream plunging at 150 miles per hour from the stratosphere. Human technology is entirely, laughably powerless against the thermal dynamics of a dipole. The atmosphere is not being steered by a switch. It is being driven by the massive, chaotic, and terrifying laws of fluid dynamics. So, what do we do with this information? As this single, massive pattern works the eastern half of the continent for days on end, your priority must be localized, actionable awareness. If you live in the northern tier, the time for complacency is over. You must have multiple, redundant ways to receive severe weather warnings. Do not rely on outdoor sirens. They are meant for people outdoors. Have a weather radio, ensure wireless emergency alerts are active on your phone, and know exactly where your safe room is located before the rotating supercells arrive. If you live along the eastern seaboard or the mid-Atlantic, your primary focus must shift to the flash flooding and straight-line wind threats. Monitor local radar for training thunderstorms. If you live in a low-lying urban area or near a creek, understand that water levels can rise from 0 to catastrophic in a matter of minutes. Never drive through flooded roadways. It takes less than 2 feet of moving water to completely sweep away a large vehicle. And if you live along the Gulf Coast, you must begin monitoring the official outlooks from the National Hurricane Center immediately. Do not panic over individual terrifying computer model runs shared on social media. Wait for the consensus, watch the stationary boundary, And use the coming days to quietly ensure your hurricane kits are stocked and your evacuation zones are known. The long, quiet stretch of midsummer weather is definitively over. The atmosphere has locked itself into one of the most dynamic, high-energy, and dangerous patterns possible. From the spinning supercells in the north, down the flooded corridors of the east, and into the boiling waters of the south, the conveyor belt is running at maximum speed. We will be tracking every single phase of this triple threat as it unfolds. Stay ready, stay informed, and respect the sky.